Okay, let's get started. So I uploaded some slides yesterday, basically where we're going to go through, I think, for the rest of the semester. So of course we could slow down, speed up, but I think this is what we'll do. If we do anything else, they won't be on the final. So basically everything that's up, that's all that will possibly be tested, maybe less depending on what we do. So this is what we're doing this week. No class next week, just if you're not aware, Veterans Day. And then what is next Friday? Exam, sweet. Yeah, so assignment 7's after that, then no class on the following Friday because of Thanksgiving, then one more week within a review, and then the final and exam week. So we have 2 graders for the class, or had 2 graders for the class. One of them resigned today, so you know, I'm not kidding. So you know that they weren't as fast as we would hope on the assignments. And with only 1 grader now, you know that that's going to be a much bigger issue. And I even talked to this person, and the grader now will not be able to get through assignment 7, let alone 8, through the rest of the semester. So what I thought would be a good idea is have only the top 6 assignments out of 8. So effectively, you don't have to do the last 2 assignments if you don't want to. But what will happen is, whatever your top 2 scores are of your assignments, they replace the bottom 2. And so that should help you some people considerably. And so here's an example here. Blackboard doesn't take this into account. It's literally impossible for Blackboard to do so, but I will calculate it at the end of the semester. Any questions on these 2 items? Yeah.
So are you recommending that we don't do the last assignment?
No, I absolutely recommend you do them, but they're absolutely not required in terms of a grade related thing.
So who's going to grade them if the grader is it?
No, what I said was if everyone turned in the last 2 assignments, we couldn't get to them. But this will help mitigate against that sort of thing. So fewer people will turn it in, then we'll definitely get them on time for sure. But it's just we wouldn't be able to if everyone did it like normal. Yeah.
Does the top score also include the bonus credit?
Yes, it whatever your top scored number is, that replaces the bottom 2. It includes bonus too. Any other questions? Okay, so I put up solutions yesterday for assignment 6. Any questions on the solutions? I'll briefly go over them. So the main thing I wanted for you to get out of this is, for something large scale comparatively like this, you have to be able to think in steps along the way, but also to think about how you're going to model your program without even programming it. So before you even write a single line of code, think about how you would even attempt this sort of thing. So I kind of gave you the solution of how I approached it. So it's based off of the points I made in the directions. First step was read a file, and so that I addressed that in the program description, the assignment description. Getting user inputs and storing them, I should say 2 vectors here. One for the character input as well as the timer input. So so reading a file, you have to do that. For this one, you could have diverged and make a class that holds a letter and a timer together so that the sorting becomes easier later. But that involves concepts we haven't talked about yet. You could use them, but we haven't talked about them yet. Maybe we'll get to them today. Finding the urgencies. What I did here was I sorted the timers first and kept the corresponding letter with the timer as we went along. So think about bubble sort, or the 2 sorts we talked about. when we do a swap of two elements, instead of just swapping the two timers, I swap the same indices of the letters. And so the letters will stay with the timer as we go through. And the good thing is that if I pick the letters from beginning to end, then not only will I be guaranteed to find the one that I want, but I'll be picking them in order of ascending timer. So I pick the ones with the smallest timers first, which is what we wanted to do if we're playing the game, for example. Then what we do at the end is we calculate all the urgencies of all the words, and then we have the words themselves in one vector, the urgencies in another vector. Then we just sort the urgencies in the same idea as when we do a swap in one, we do the same swap in the other, and then print at the end. So what I did was I made this handy function basically to figure out, is this word possible with the letters that the user inputted? If not, there's no way we can use that word anyway. And so basically, this condition right here says, if the number of occurrences of some character in the word from the file is more than what the user inputted, then there's no possible way we could use that word because of that one character. So we return false there, meaning that the word is not compatible. But if we go all the way through all letters and it was okay all the way through, then we return true. So here's how the program works. We input an integer n, which is the number of words we want to print. Then this loop right here just gets the character in the timer and stops when they enter -1. So it could either be for the character, although there's some things you have to do there, but it could be either for the character or the timer. Either way was okay. So I get the input file, then I call getLine to read each line in the file. I determine if this word is compatible, so because each line is one word, I just figure out, is it okay? Then if it is, then I push it into a vector of compatible words that I maintain. So this loop right here is basically just copied bubble sort. So you could have just used the bubble sort implementation we had. Then what I do is, I could have done the swap myself, but I figured there's a swap function already, I'll just use it. So I swap the corresponding timers, and I correspondingly swap the same two input characters, so everything is in sync. Then here's the meat of the program. So I go through all compatible words. I make a copy of the timers, because what I do is I look for the first occurrence of a timer for a character I haven't used yet. So if I've used it before, I don't want to be able to use it again because I can only use each character once. So what I do eventually is, right here, I set the corresponding timer to -1 to say this is not a valid timer anymore. And then if we see, oh, this is the character I want, but it's -1, then I'm going to skip over it. And the reason why I make a copy is I don't want to modify the original timer's vector, because then I want to use it for the next word, but if I put -1s in there, I've thrown away the corresponding timer that was there. So I make a copy here. And then what I do here is I loop over the word, and then this basically right here just figures out what the next highest timer of this character actually is. It just keeps going, and then if we get to the point where the word corresponds to the character that we want and the timer correspondingly is not -1, then we found the timer we want. Then we find the timer. We set the same value back in the copy to -1 so we don't use it again. Then we update the urgency. But remember, at the end, the urgency has to be multiplied by 1.1 to the n, which is the word size. And then we push back the urgencies, that value into the urgencies vector. Right here, this is basically just the same idea as earlier, but I flipped the comparison here so that the urgencies are in descending order instead of ascending order. Either way was okay, but you just had to print. I figured that if you put the highest urgencies first, it would be easier to print, but either way is okay. but I do the swap of one and the swap of the other in the same way, just as before. Here, if I have like say 10 words, but the user wants 20 words, like only 10 words work, but the user entered 20, then if I try to print 20 words, then I'm going to get an error. So what I did instead is I took the minimum of those two. So if the user entered 20 and there were only 10 words available, I only print 10 so that we don't have that issue. But if I have like 100 words available and the user entered 20, then I print 20 as expected. Okay, and that's the whole program. Yeah, go ahead. Okay, so this was the ternary operator. For some reason, I couldn't get the min function in the standard library to work, but all this is saying, I'm not sure if I went over this, but it's not required that you know this. You could have just easily said, if this, then set m to be n, otherwise set it to be the size. So this just says, if this comparison is true, then the resulting value is n. If it's false, then it's the size instead. So it's like, if this, then the first thing, and then otherwise the second thing. But you could have easily written an if-else statement here. But I figured it was just quicker to write this. But any other questions about the solution? Any other questions in general? Mm-hmm.
A guy yesterday was talking about the parenthetic thing. He said that's like so much more efficient than anything else.
It does literally the same thing in code. Yeah, so I could verify it for you, but I'm telling you it does exactly the same thing. Yeah, yeah.
So one guy recommended for the term the calculated efficiency is using classes.
Yeah, so that's one way you can do it. But the issue here is if I want to sort a list, let's just say we put the word and the urgency in one class, for example. Then if you have one word and one urgency here and one word and one urgency here, how do you compare them? So obviously the answer is you got to compare the urgencies, right? So like I say, this one is better if it has a higher urgency than this word, right? But the issue is now I got to figure out how do I sort based off of that? And when I do that, I have to actually look up the urgency of that object to compare with the urgency of this object. And so that could be a little bit cumbersome. So one thing that we're going to see today is, or maybe next time, is something called operator overloading. And what you can do there is say, okay, I have this object and this object. Can I define what the less than operator means? So like we can compare two integers or even two strings, like 5 less than 7, for example. There is an operator for that, the less than operator. But if I have two objects, what if I wanted to compare objects that way? So maybe like one string is longer than the other. How would you implement that? So we're going to see how to do that. So it makes classes much easier to do, especially if you want to sort a bunch of objects. How do you compare the objects? Because then you have to think, okay, I got to define this to compare against this, and you could do that, but it's a lot harder. And this is a lot easier. But any other questions about the assignment? So who hasn't started assignment 7? What do you think I recommend? Start assignment 7. Okay? So it's not nearly as hard as this one is, but it requires some different thinking processes because first off, you got to make plots, and we haven't made plots before. But you can probably figure out how to do that in like Excel or Numbers or whatever. So you got to think about that, but you also have to think about how do I structure this program to make it easier for me? I implemented it myself, and it doesn't take too long to run, thankfully, so that should be good. But we'll see what happens. Other questions, though? Okay, so let's get back into pointers. So I'm going to briefly wrap up pointers because we're pretty much done with them. So the last thing we talked about last time was these things called, where is it? Smart pointers. So what's the purpose of a smart pointer? Anyone remember? Why don't we just use normal pointers all the time? Why do we need smart pointers? Yeah. Yeah, so dangling pointers are definitely an example of this. Anyone have well, it's in the slide. So, I mean, you're technically right, but yeah, these other things are important too. So if you have like two things pointing to the same place, maybe you don't want that to happen. So smart pointers help you with that. So what are the two smart pointers we talked about? Unique pointer and shared pointer. So unique pointer is only one owner of an object. Shared pointer means multiple owners of the same possible of the same object. So unique pointer is pretty simple. Basically, there's only one way that you could have an owner of some object. If you try to assign one unique pointer to another, you have to call this function move in order for it to work. And we'll talk about the move function in a bit. Not here, but in the useful classes part, I think. Okay, so then yeah, you can have unique pointers of arrays if you want to, but it's not necessary. So for shared pointers, we can have multiple things pointing to the same object, but so it seems like it has the same issue as before, but what does a shared pointer have versus a normal pointer that allows us to say, if we have two things pointing to the same object, and this object says delete the value that it's being pointed to, what happens here? Then it starts to point to garbage memory, and that's undefined behavior. So what does a shared pointer do? It has something called a counter, a reference counter, right. So if we have two things pointing to the same object, then there's going to be a reference counter that says, okay, there are two things pointing to this object. And then if this one says, okay, I'm going to delete myself right now, what do you think is going to happen to that counter? It's going to go down by 1. And so, so the timer is still 1. Since it's still 1, should I delete the object that it's now pointing to? If the counter is still 1, not 0, should I delete it? No, because it's not 0, something is pointing to it. And so if that thing tries to access the thing, then we try to get garbage memory. So it has this, where is it? Yeah, it has this reference count which tells you how many things are pointing to the object, something we didn't have with normal pointers. And so now when it decrements to 0, like say the last one frees itself, then we can delete the object because we can be guaranteed nothing is pointing to it. And so it handles this dangling pointer issue that we had before. Yeah, so the very last thing I wanted to talk about, so this is where we ended last time. So what I recommend here is, yeah, try not to have two control blocks for a shared pointer. You only want one over one object. Yeah, so try not to do something like this. But of course, instead of just declaring a shared pointer and then calling a new int, for example, in the constructor of it, we can call make shared. Like make unique, we can call make shared instead. So you don't have to say new, it does exactly the same thing. And I prefer this much more over calling shared with a new inside of it. Okay, any questions about pointers in general before we get on to the really cool stuff that separates C++ from everything else? Okay, so let's actually make classes useful again. So, so up until now, we've been basically at the point where everything that we've seen is pretty much implementable in every other programming language. So like if you move to Java or Python or Rust, for example, everything that we've done here has an analog over there. So it's not like we're doing anything useful. And so you may be thinking, okay, what separates C++ from every other programming language? And basically we're going to get into all that stuff for the remainder of the class. So the first part is we talked about these classes, and basically the whole purpose of them is to hold data privately and then have some operations that are defined publicly. That's the only reason we had classes, to wrap up data for us. We saw with the RAII, the resource acquisition is initialization examples, that classes are useful in the sense that if we have some dynamic memory in a class, then in the constructor, we can initialize that dynamic memory and free it in the destructor. So that's one use of a class that separates it from other languages, but that's all we've seen so far. So let's get into what really separates C++ from every other language. So the first one is something called a copy constructor. Although this isn't really separating it, it leads into things that do. So I'll get into an example in a bit, but a copy constructor is, instead of saying, okay, I have this object I define in main, so maybe CP class, for example, and then I want to copy this object into another. So actually an example of where this is useful is back in my solutions of the assignment. So note here that I make a copy of the timers vector, right? Because I don't want to modify the original. Well, one way I could have made this vector is just called vector int timers copy just by itself. And then for each element in timers, I'm just going to push that element back into the timers copy. So I'm looping over the timers vector, and then I'm just going to copy them one by one into the timers copy. That doesn't seem like something that I should be doing. I should have the vector class have some mechanism of doing that for me. And so this thing right here is I'm calling the copy constructor. So a copy constructor is you take an object of the same type, so in this case a vector, and then I copy all of the contents in there into the brand new object that I'm making. So we don't have to put the burden on the user of the class to say, move the contents over for me. I'm going to do it for you in the class. So how would we even do this? So let's just say that we go back to our stuff here. So let's make this CP class here. So this CP class definition doesn't actually have a copy constructor yet. Let's avoid the issue with pointers and whatnot. Let's just say this, for example. Yeah. And then we don't have to worry about delete now. Why? There's no pointer, so I don't have to have a delete. And in fact, I don't even need a destructor because I don't have anything dynamically allocated here. But let's just say we have this data and then maybe string S in here, and then S is CSE100, for example. And then I could say, user, if you're going to use this class, you have to copy the integer p into the new object you make and the string s, which could work. But what if I decide to put another piece of data in here? And then the user, would the user have to update their code now? Yeah, so if they had to copy the elements all themselves, then if I put more data in here, they have to handle that themselves. So a copy constructor is, I only have to do the implementation in the class. I don't burden the user with it. So how do you make a copy constructor? Well, you make a normal constructor like this, and then you take a constant reference to an object of the same type. So I make a CP class other like this, and then here, can I access the variable? Yeah. So here I say, well, this other object that I'm trying to copy into, copy from, it also has integer p and a string s. So it has its own p and s. I want to copy them to my local variables in this particular object. And the way you call that is with, you can use something called this, but this is not, in this case, is not even required. So I'm just going to say p is other dot p, and then s is other dot s. I hope this works. Yes. Okay, good. So this is a copy constructor. So you take an object of the same type. By convention, it's a constant reference, but it doesn't have to be. But you take an object of the same type, and you copy the elements over to this object. So like for vector in the solutions, one method would be you copy the contents of the internal array over to the object that you create. So if I add more data here to this CP class object, I only have to modify the copy constructor. I don't burden the user with copying it myself. Okay, so the issue here is so copy constructors are awesome because you can just copy all the data if you need it. But the issue comes with if you have dynamic allocation because of the issue where, so here's a reason why you should use smart pointers for this example. But if you use raw pointers, it could have an issue because we can have 2 pointers to the same object possibly in here. So yeah, so if you copy assign some object over here, then C2, so when is C2's destructor called? So I define C2 in this if statement. When is its destructor called? When it leaves scope. So when does C2, not C1, C2 leave scope? At the end of the if statement, because it's defined in the if statement. Remember, scope is when you encounter the closed curly brace. So when the C2's scope leaves, which is right here, its destructor is called. And if you remember, the destructor here is delete this pointer. But if you have 2 things pointing to the same object, we have this issue of a dangling pointer again. So this could potentially cause an issue. But of course, we don't want the user to be burdened with, okay, there's some dynamic memory allocation here. You have to handle it yourself. The copy constructor should handle this for us. Yeah, so this is basically what I said. So here's a word of advice. The reference parameter should be const because we don't want to modify the original, but it's not required to be that way. So copy constructor avoids problems, or should avoid problems because of this dynamic memory thing. It should allocate separate memory to hold new objects' dynamic member data. So you don't have 2 pointers to the same object. So the way to fix this is so here's the copy constructor right here. And then basically we're just going to make a brand new integer. And then here we're doing an actual copy. So when we try to copy construct this object, I'm going to make a brand new copy of the object, of the integer here. So we don't have this memory allocation issue where you have 2 things pointing to the same place when you assign a variable or copy a variable. So when a copy constructor is called is when you initialize an object with another of the same class. So here, actually that's not a good example, oops. So if I make a CP class, let's just say 5, let's just call it C1, and then I make a CP class C2, and I'm going to pass in C1 here. So I'm doing a copy construction of C2 from C1. So this C2 constructor is calling this constructor the copy constructor, not the initial one. So so just keep that in mind if you want to copy some value with another. So like in my solutions, I'm copying a vector to another vector. Okay. So when is it called? This first one is when we, this one is the example I just gave. The second one is if you return a value from like a CP class, for example, from a function by value, then what happens if you're using an old version of C++? So what happens is you're going to be copying from where the function is to wherever the caller of the function wants that value. So if I have a function here, so let's say that we have a CP class function f. So let's make an object in here and then return C1. So if I instead said, okay, instead of initializing C2 from C1, I'm going to call f instead. From here to when this comes back to main, that's calling the copy constructor. Because I'm returning by value a different copy. In recent versions of C++, we're going to get to this. This is not always true, but a lot of the time it actually is true. So when you return something from a function, you're calling the copy constructor. Oops, I don't want that anymore. And then, yeah. Sorry, I mixed these up. So the third one is the one I just said. If you pass an object by value to a function, so in this case, like if I took CP class f, and then, not f, g, for example, and then let's just say copy construct C1 here, and then here in f, I need CP class myself, so let's just call C1 and initialize it with 5. Then if I call f of C1, when I call f of C1 here, from here to here, from the call to f to when g is initialized, that is doing the copy constructor too. So in fact, we're having a lot of copies all over the place. So interestingly enough, so C1 is copied to g. In the first line of f, I'm doing a copy construction from G to C1, and from C1 back to C2 in main, I'm doing another copy. So one of the sins of C++ is that it likes to copy things way too much, right? So we're doing 3 pretty much unnecessary copies here because really all we're doing is just passing one value from one version of the CP class to another. So that's kind of annoying. And we'll try to get to something that avoids copies later. But any questions on how the copy constructor actually works, just in general, at a high level? Okay. So, but other functions have, other programming languages have copy constructors. So what? But a lot of programming languages, in fact, I think only C++, maybe a few others, have something called operator overloading. And so copy constructors lead into this thing called operator overloading. So what is operator overloading? So if we want to say, what does it mean if I take a CP class, another CP class, and I add them together? So I call plus between these CP class objects. I could define a .add function, and I could just say, okay, if you pass me this CP object, then I'm going to do the calculation and return a CP object to you. So we can actually see that happen. So maybe I define a function called, I return a CP class, I call it add, and let's just say I take in a CP class other, and then what we would want this to mean maybe is I add the 2 p values, for example. So maybe I make a CP class s, and then I'm going to set s.p to be, let's see. So it'd be the p from this object, and then the p from the other object. And then I return, I return s. And so I could define this. So I could say I'm making a CP class eventually to return, and I'm defining add between these things to mean I'm going to add the 2 integer values, the one from this object and the one that I'm passing in called other. And then I return the one that I created, And that's the addition of these two objects. So maybe we can define it that way. But it seems kind of annoying because if I make two objects, let's just say C1 and C2 here, then CP class C3 I could say is C1.add C2. So we could do this, which is fine. But it seems annoying to do this because then I have to call this function on the result. And in fact, I'm going to do an unnecessary copy here because I'm returning from this function by value. And so I'm going to get a lot of copies unnecessarily out of this. So what is the solution here? Is to use operator overloading. So wouldn't it be a lot better if we just, instead of using .add here, we can just say plus here? So it's a lot easier to, so it's not defined. I haven't defined it yet. But if we could do this, this would be a lot better. But the really interesting part of operator overloading is I can overload any operator. I can overload the star operator. I can overload equals. I can overload minus. I can overload divide. I can overload the not operator, the tilde operator. All of those I can overload to mean something that's useful for the class. So where would this ever be useful? So how many of you have taken some math class on like matrices and vectors, linear algebra, that sort of thing? So one thing that would be really nice here is have a matrix and another matrix and define addition for them. So I could have a function .add here, but it just seems a lot better and a lot easier to read if I just put plus there. So that would be useful there. I can overload the star operator to actually mean times instead. So maybe I can take a matrix and another matrix or a vector of the same of the right dimensions, and then I can define times in the right way. I can define divide to mean I can mean to mean take the inverse of this matrix if it's square. So I can define a whole suite of operations, and I don't have to make a function name for that. I can just overload the operator, which is really, really cool. So how would you actually do this? You would just change add to operator plus, like this, I think. Yeah, so in fact, I can define plus that way. So the really great thing is that this was a very small change, but it improves readability a lot, which is really cool. So, and operators can be combined. So remember plus equals or minus equals or whatever? I can combine those two operators in one. So you can overload any operator, I think, pretty much that way. So if we have this class, OP class, or OP class, I don't know, operator plus, this one takes it by value. You could take it by const ref. It doesn't actually matter here. But the important thing is that we're redefining what plus means between two objects. Interesting thing here. Does it have to be OP class? Remember to the copy constructor, I said by convention, the object has to be the same type. Does it have to be? In fact, it doesn't. And here's actually one example of where this could be really useful. So remember string. So like we can have like a string s is equal to CSE100. What is the type of the thing on the right side? Is it a string? It actually is not a string. Believe it or not, it's not a string. It's something called a const char star. So you can think of this as an array of characters. So an array of characters is not a string, but there's an overload for the operator, the assignment operator in this case, to say I can take things from a string or I can take things from a const char star, meaning a string literal here. So instead of having to say, oh, I'm going to make a string out of this and then assign it to this string, this seems a lot worse to do than to say this. So the thing is, instead of having the copy constructor or the operators to say, you can only take things of the same type, you can take things of any type. So I can define, for example, if I'm making a string class, I can say, what does it mean if I have an int that I pass in? Or if I try to add a string in an int? Or if I try to add an int to a string? I can define all of those, which is really cool. So instead of having to convert the integer to a string and then add them together, I can define it right here and put much less burden on the user to do it themselves, which is really awesome. So, so in this case, I can define operator plus with the same type. I can define operator plus with a different type, any type that seems sensible to what we're actually doing, which is, yeah.
So if you wanted the plus operator to, in this instance, add whatever the input is to x instead of...
Yes, I can do that exactly the same. So, yeah, I see what you mean. So we can even do this. So let's go back to this example that we had here. So I could say C2 is C1 plus 10, but I haven't defined a plus. Oh. Okay, maybe I have to do this. Let's see. Yeah, okay, so that's an interesting consequence. So ignore what I'm about to type for now. So we can see that there's an error here that says we can't convert an int to a CP class. So we can just say, instead of having to write an overload for this, I'm gonna have an operator plus which takes an int other. And then I'm gonna redefine it to be, well, an int doesn't have a member data called p, but I'm gonna add it to the other, and then this works just fine. So I can have any type there. So why did I have to put explicit here? So this is actually really interesting, or at least I think it's interesting. So if I remove the explicit here, this actually works and it compiles. So what actually happens here is it says, okay, you have a constructor which takes an integer. I can actually implicitly convert this 10 into a CP class. I can implicitly convert it, and then I can call operator plus on the copied version of it. So we won't talk about explicit. I won't test you on it, but it's just something to think about because here weird things can happen. So if I instead have a string m, and maybe I can default initialize it to CSE100, and then I set s to m, I think this will not work. Or maybe it does. I learn something new every day. Yeah, I'll have to think about why this still compiles. It shouldn't compile. But the key here is that it's able to deduce that I want to convert this 10 into a CP class and then copy it over. But the takeaway I want you to get is every operator does not have to take an object of the exact same type. It can take any type at all. And so I can redefine anything, any operator to do anything on any other type, which is really cool. Of course, this could be generalized way too far, but the fact that we can do it makes our code a lot more readable. Yeah, so if we define it out of line, we have to put the class with the colon, same as before, nothing new there. Yeah, and we have to access variables using this so that we can actually access the internal variables in this case. But I won't test you on the this operator. Yeah, so I could say a.operator plus of this thing if I wanted to, but the far better way is to say s equals a plus b. So like for the, if you remember way back to assignment, I think 3 about in and out menu, then we can say, I'm going to add this menu item to the order. So maybe we make a menu item class and we add it to an order class. Then I can add, I can overload the plus operator between a menu class and an order class to mean, okay, I'm going to take all of the data of this class and then move it over and then put it into my menu. So instead of having to make gazillions of variables to hold the data that we need, we can just put it into a class and then overload the operator. And then it makes our code much, much more easily maintainable and readable. And the thing is, there's only a very small change. You only have to change the name of the function. You don't have to do anything else, which is really, really cool. Okay, so this is operator plus, but of course we can overload any operator, including the assignment operator. So here, instead of saying operator plus, maybe we could also say that we want to overload operator equals. So this means that I'm trying to assign a CP class into another CP class object. So instead of copy constructing the object, I'm copy assigning the object. So here I can say, well, instead of doing this equals C1 thing, I can say, so I can say that S equals other dot S, and then P equals other dot P, and then return, Actually, I have to do this. So S dot S is a horrible name for it, but I could make an object right here, copy the data over. Oops. I can copy the data over, and then I could return S that way. So I can overload the equals operator this way, which, so the convention, of course, is that we want the thing on the right side to be initialized, the thing on the left side to be initialized with the stuff on the right side, from right to left. But of course, we can put any code in here, so don't go overboard with it. But of course, we can overload the assignment operator. And we can mean that to do depending on what we want to do. So like for a unique pointer, so if you try to assign to a unique pointer from another one, then because it's a unique pointer, we should null out the data inside the one we're assigning from, because we want it to be a unique pointer. So it overloads the operator equals, in this case, the overload assignment operator. Okay. So here's an example. We've already seen that. Don't worry about the star this stuff. The point is that we can overload operators this way. Okay, so just some things about this. The operator itself can access private members. Even though you're passing in a completely different object, you can still access the private variables of it. And it makes sense to want to. You want to copy the data over to the other one, and so it makes sense that you want to access private members this way. Overloading can change the entire meaning of the operator. I can define plus in any way I want, but of course we want people to use our classes, so we want to define it in a useful way. There are some operators you can't overload, and I can't remember what they are, but most of them you actually can. And what should be returned depends on the operator. So if we overload the less than operator, what should that return? So if I'm comparing this OP class to this other OP class, what should less than, for example, return? A bool, right. So the what should be returned depends on the operator, and you should abide by what it actually should try to do. Okay, so we'll start our value references next time.